Hello and welcome to the beginner's course in the structural design of building using Protastructure 2022. My name is Engineer IC Friday, your instructor. At the end of this course, you will be able to study any architectural plans and then plan your structural columns, after which you will be able to model the structure, load it, analyze and design all of the structural members, and then you will be able to generate a detailed structural drawings of any architectural building plans successfully using Protastructure 2022 version. So let us take a brief study of the architectural plan, the 3D, as well as the elevations of this building. This is a duplex. From the 3D, zoom closely, you notice we are actually having a slender columns, 4 of it at the right front of this structure. So in the 2D, you can also see it right there. And then we have as well a cantilever right there. So coming down to the plan, you will notice we have about 3 bedrooms right here, including the foyers and a sitting room. So for the full plan of this, you can see we have the site plan right here, and then the ground floor plan with the first floor plan. At the ground floor plan, we only have guest room, laundry, study room, dining, and sitting room, including foyers. At the first floor, we have about 5 bedrooms, including master's room, right here in this plan. Here is the roof plan section, structure. We have the front elevations, left, rear, which is the back view of the structure, as well as the right side elevations, this structure successfully. And so I will be leaving a link for you to download the complete architectural drawings of this building, including doors and windows schedules, in the description of this video. So you will also see the 3D of this structure after you get the files downloaded successfully. So let us start to plan our structural columns. At first, before you should take your structural plan to the Protastructure, you will need to make sure you create a grid lines through the layers. Layers property. Click in these provisions. You have to create a new layers and name it as grid. You create the second one and as well name it as columns successfully. And so what I have here are my grid lines. I've already name and then assign all of the grid line to the center of the wall. Also, my columns has also been named correctly and accordingly. So to plant your reinforced concrete column, you will have to now come into paneling. Paneling has to do with you checking the provisions or the area bounded by the beams, and then paying good attention to the spans between the 2 points. For me, since this is a story building. I take my maximum distance to be 5 meters. Alright, so the more span you have, the more reinforcement it will actually generate, okay, due to deflections and movement that will be generated at the anchorage, okay, of the reinforced concrete beams and columns successfully. Alright, so this area, all of this area, we've taken it to be a panel. Alright, and then all of this area is also a panel. So that is why you see 4 columns binded it together, although I wouldn't mind to remove all of these kitchen utilities. Okay, I can get rid of that. It's not an issue, or I can as well leave it. So by the time I get these plans to Protastructure, you wouldn't see all of those kitchen units, because Protastructure cannot detect all of that. So the only thing the Protastructure can detect here is the grid lines and the reinforced concrete columns layers. Okay, so these are the 2 layers that is very necessary. You create in AutoCAD, alright, and then plan them on their breeding plan successfully. Okay, so having done this successfully, the next thing you will do, you have to check the architectural plans to see where you should have a cantilever or not by superimposing the architectural plan. But since this is a simple structure of a story building, if you check very well, you will notice that we are only having some just a cantilever here. You can see it's being demarcated from these provisions. At the upper floor, we have it, the wall covers, okay, along the rear side of the structure. Okay, so the front are almost the same. So where we are having cantilever is this provisions, this place. Okay, we have a little cantilever there, slab, and then we'll have cantilever slab here, including this encrust. Okay, the sit out here, I have a little cantilever slab, that's all. Okay, so everything is understood. Now, after having planned your reinforced concrete columns layers successfully, the next thing is to take this this structural plan, because this is now structural plan. This one is the architectural plan. Okay, this one is the architectural plan. This one that we have planted are green lines as well as the columns layers. Okay, is now our structural plan. Right, so we need to take the structural plan to the origin of the universal coordinate system in AutoCAD. Alright, so for you to do that, you just have to click on line or type L on the keyboard and enter, and then 0, 0, just like this, enter on the keyboard. So this has actually located, okay, a start point. Okay, that start point, just have to click anywhere else and zoom it closely. So once you zoom it closely, you will notice that we will have all of these plans very distant from the origin of the universal coordinate system. Okay, so this is the origin. So we need to take this plan all the way to this origin right here. Okay. Now the reason why the structural plan have to be taken to the origin is because we want it to appear at the origin after we import it from AutoCAD into Protastructure 2022. Alright, that is more reason we want it to be at the origin. So we are going to move this plan right from its location, present location, to the origin of the universal coordinate system. Okay, these provisions. So we can just highlight all of this. M on the keyboard for move, and then move this closed just like this. Okay, now zoom it closely to the structural plan. Highlight all of the structural plan, and then let's copy that CO on the keyboard. Trace these two ends grid line, then take it to this origin and place it here just like this. Okay, now this is just for reference purpose, the line. Get rid of that by deleting or erase that up. So now we get this plan at the origin right here. Okay, we want to convert this plan to an AutoCAD format called DSF. Okay, so Protastructure is able to read DSF and not DWG. If you check over here, you see the file format is DWG. Okay, we also have another format called DSF. Okay, so before then, you should have to take note that at the entrance right here, we have two circular columns, right? So we should have to take note of all of these successfully. Okay, now select all the plans, all the structural plan now like this. W for right block. Okay, so in the right block dialog, we click on these three dotted provisions. Before then, you have to select your unit of instructions, which is millimeters. You take note of this unit of instructions. Click on the three dotted provisions. So this will take us to directory. We have to save this file successfully. Okay, so the file type have to be changed to DSF right here, and then give it a name as a structural plans. So after which we save it to the desktop. Click on save right here, and then click on OK. So this will automatically save that file to the desktop. Okay, so now we save the file to the desktop. We have to launch Protastructure. Okay, so here is Protastructure 2022 first interface. All right, and so if you want to launch Protastructure, you want to launch it, you just have to double click on it on this desktop. So here is it. Or once double click on it, it is going to launch successfully just like this. So the first thing you need to do is to create a new project. Okay, so you click on new project right there. So in the new project dialog, you give it a project name. Okay, so we can call this structural. So structural underscore design. Okay, can also have another underscore of underscore building. Okay, so you can always use an underscore to separate the project names. Okay, as a spacebar. Okay, you use underscore as a spacebar to actually separate the names. Okay, so the next thing you need to do is to select your code of practice depending on your country of residence. Okay, so we have various codes right here. Okay, but for the sake of this course, we'll be considering United Kingdom Euro code for this design. So you get the code template selected, click on the OK. So you have to just give the program some seconds to load the United Kingdom Euro code template. So this is the code we are going to be using for the structural analysis and design of the building successfully. So now the code template is ready. Okay, what you have to do is to now navigate to the modeling tab, but by then in the building setup tab, presently we have to import the AutoCAD file we save to the desktop by clicking on the DSF import. So this will open to us DSF import dialog. In this dialog, you will have to set the unit of file that you are bringing into Protastructure. So the unit of file is in millimeter, just as we have saved it in the AutoCAD. And then the type of file you are importing is very important. So if we check here, we have three options here: physical model, analytical model, and then floor plan is what we are bringing in. Okay, so we select that successfully. So every other provisions you can leave it at default, and then click on the load DSF. So you navigate to the desktop right here. So in the desktop, you can't look for the file. Okay, so the file name is structural plan, which is this one. Okay, click on to open. So it is loaded successfully. Alright, and then if you check very well, the members we have there are grids, with the layer name is grid line. We also have columns with layer name is column. We have walls, but this we wouldn't have wall, okay, in this structure. Okay, but Protastructure take area that is bounded by a particular line as a wall. Alright, but we have to uncheck here because we don't have wall, okay, as intention. Alright, in this structure. So after which, click on the import. So the import is in progress. So it is going to import all of these layers by converting our grid line layers to Protastructure grid lines, and as well convert the columns layers to reinforced concrete columns 3D sections in Protastructure. So the import section of the structural plan is successful. You just have to click on the close options right here to get right out there. So here is the plan. So you can see now the structural plans columns right is on the origin of the universal coordinate system of the Protastructure, because we move this plan to the universal coordinate system in AutoCAD. So you can see in AutoCAD is exactly at the UCS icon right here. Same thing in Protastructure, okay, at the same positions. Alright, so if your structural plan is very distant from the universal coordinate system origin, you may not necessarily found it in the Protastructure. It will be very distant from here, so you have to zoom in, zoom out to be able to get it right. Okay, so having gotten the structural plan in the Protastructure 2022, what you have to do is to study the grid lines to see how orderly arranged they are. So if you check very well, you notice the grid lines are not properly arranged. Okay, so what you have to do is to rearrange the grid lines by renumbering it. So we can take the vertical grid lines to be arranged numerically, and then the horizontal grid line to be arranged alphabetically. So let's proceed. You have to zoom close so you can see the grid line numbering successfully. Get all of that selected. So after which, right click and then hit property. So in the property dialog, you move it downward so you can be able to see the numbering right there. A1 supposed to be 1, okay, while A20 supposed to be 2. Alright, so what do we have here? You can see here to be A6, okay, something like that. So this is 3, and then A19 is 4, A7 is 5. Alright, so A2 is 6 right there. So this is how you number the grid lines. From in the vertical axis, you have it from 1 to 10. So click on closed. So you have this, okay. So in the horizontal grid lines, since it is much, so you have to just zoom so you see some of it very well, and then start from there. Get all of it highlighted. Click and then select the property. So in this, A8 is going to be A. So you make sure it's capital red, okay. A, alright. 9 is going to be B, alright. Having done with this from A to F, you close this dialog, then zoom again closely to the remaining from F. So we have to select the remaining one, right click, and then hit property. So we stop at F, so S17 is going to be G, this one, and then 18 going to be H. Alright, so after which we click on the closed. So we have a grid lines from A to L right there. So after we must have done with grid line editing, just like this. The next thing we'll do is to now start to create the beams. Alright, but by then we will have to set the stories, okay. So you can do either of the two first. Set your story first before you create your beams, okay. So it all depends on which you will do first, okay. But by then you have to carefully check to ensure that all of the structural columns that you layered and planned in the AutoCAD is being imported successfully, okay. So having to confirm that, you will now have to proceed to model the structural beams, okay. But in the aspect or area of grid line numbering, you must ensure that you check your architectural drawings, alright, to also maintain the grid lines that is on the architectural drawings. I just want you to have knowledge of this, okay. Let your architectural drawings grid lines be the same with the structural grid lines, okay. So if there is any alteration, it should be specified, okay, so there will be no contradictions, okay, during the reading of both plans at the construction site. So we proceed to the modeling tab right there, but we then have to save this project. So click on the save to make sure this project is properly saved so as to avoid loss of files, okay. You navigate to the modeling tab, and then we want to place the structural beam, so click on the beam icon right there. So in the beam dialog right here, we have the general tab, so we can see the label as the first beam is going to be 1B1. 1B1 simply means the beam at the first floor, okay, and then the B in the one in the front of the B simply means it's the first beam, while the one behind the beam simply means it is the first floor. Okay, but we have not set story. So at default, you have Protastructure having story 0 and story 1 at default. So the distance between story 0 and story 1 at default used to be 3 meters. So that's why you're having it 3 meters right here in this structural 3 provisions. Alright. So coming down, so we want to have a normal beams. Okay. Also have other type of beam like wall coupling beam. Okay. Which in the subsequent video I will explain this to you. So don't forget to like and subscribe to the channel so you stay connected. Alright. So over here we have the sections of this beam. So over here in my country we do have 9 inches blocks. So that should be the thickness of my beam. Okay, because that is my wall sampled blocks. So I have it to 2 to 5 right there. And then at the first floor we can start from 450 millimeters depth of beams. Okay, after which we wouldn't want to inch it. We'll take time to inch and anchor these beams to the columns successfully as it's supposed to be done. Alright, so we wouldn't inch it at first. Okay, so we start to place the beams according to the wall that we have in the architectural plans, and then with respect to our panels that we have already cut. So we should be having a beam right here from this column to this column, and then we would go ahead to connect these reinforced concrete columns. So we have a continuous beam that we connect up to this point. We have another continuous beam that goes across to these other provisions. So beam here, connect this. Alright, so based on what you are seeing in the AutoCAD panels that you have done, so you just have to follow that successfully. After which we proceed, we have another beam connecting these 2 columns, this and this one. So we have a beam over here. Mind you, these columns have to be a slender columns, so they are not supposed to have a beam at this first floor. They're supposed to have a beam at the roof level, but we will correct that as we make progress. Alright, so take this beam all the way down. It's a continuous beam, so you always right click to get rid of the command. So we'll continue from this point, take this down and connect this right here. Okay, so we wouldn't supposed to have beam here as well, so we'll get rid of this beam. Okay, because this is a city room, there should be no beams right there. Okay, so if there should be a beam, maybe due to the area to be covered by the reinforced concrete slab, we should have a concealed beam and not a normal beam. Okay, so we look at that shortly. Let's proceed. So we placed beam here. We also have a beam here. Don't forget this provision is the stairway. You can see over there. Okay, so we'll continue to connect the beams. So this will be connected there, and then we have this one all the way, the provisions. Okay, we do have a beam right here, but not really here, because we should have a beam here. This is where we have wall at green lines, C, we have a wall there, so connect a beam there. Okay, this is fine. Okay, so we are having a kind of cantilever slab right here, and there is no grid line for that, so we need to create a grid line for that cantilever slab successfully. So I want to place this, come over to these provisions. We do have a beam for here as well. We will have another beam in the provisions. There is a beam here, and this place will have a beam here. Okay, so here is the beam system we have actually generated successfully, all right, based on the architectural plans. So let's get this maximized successfully. So with this over here, as I said earlier, we are supposed to have a concealed beam because of the large area to be covered by a slab to avoid deflections. So for you to get this beam, normal beam, converted to concealed beam, you will have to get to the property of this beam. Alright, so in this property of this beam, what you have to do, haven't noticed that the depth of the beam is 450, so it's going to take the depth of the slab, which is 150. So what you have to do here is, instead of 450, you should have 150 here. So what is left, use it to compensate the width of the beam. Okay, so if you subtract 150 plus 450, we should be having 300 right there. So here is going to be 150, which is the depth of the beam. So we have 300 plus 2 to 5, so we'll have 525. All right, so it's going to be 525 right here. All right, just like this. Click on the update, so you have something of this kind. So this is now serving as a concealed beam. Okay, so you will use the depth to compensate the width of the beam to have a concealed beam. Okay, which will help us to strengthen this reinforced concrete slab areas. Okay, which is more than 30%, because if your reinforced concrete slab area should not be more than 30%. All right, so anything more than 30% of your reinforced concrete slab area should be introduced a concealed beam. When I said area is when you multiply the length of this is about 5 point something by the width. So this width is about, total should be about 6 point something, alright, including this. Okay, so once you multiply that area and it gives you something that is more than 30%, okay, you have to introduce a concealed beam, which is what we've done here. Okay, so as to avoid reinforced concrete slab failure and also deflections. Okay, this provisions is the stairway, which I've explained earlier. So the next thing we have to do now is to place a reinforced concrete slab right here. So, but by then we need to offset. These grid lines forward. The grid line B will offset it downward for the cantilever slab. Okay, for the sit out. So you right click right there and click on the offset options. So move your hand downward, hold the shift key and then F2 to have a prompt to key in the distance. So I propose 50 minor since we are going downward. Okay, and so it's going to be 1200 millimeters and enter. So you have this. So this is now giving us as M. So you can rename this as A prime. Okay, or you can rename it as A1. Okay, so since it's a new grid line, you can click on the property and then we have M right there. So let's call it small A1. Okay, click on the update. So we have something of this kind. So this is fine now. So at the first floor, you can as well still have a beam right here, which is going to actually support this, because all of these beam won't be here. We will get them off because looking at the 3D, we wouldn't have beam in these provisions. All right. So we proceed. Let's check the property of this beam. We'll use this in these provisions. So close this, and then for the reinforced concrete slab, you have to enable your loading combination first before you carry out the reinforced concrete slab placement in Protastructure 2022. Alright, so we get to the loadings right there, and then load cases and combinations options. Click right there. You have this loading generator. Okay, so this is going to give us the loading combinations with respect to the code of practice that we are using, which is the United Kingdom Euro codes. So we wouldn't consider the horizontal loading combinations because we are not designing an IRS structure. So click on the OK options to generate these loading combinations. Alright, for the live and dead load successfully, click on OK options, after which we navigate to the modeling tab. Click on the reinforced concrete slab. Alright, so in the reinforced concrete slab dialog, we have various types of slabs here, but what happens is this: in Protastructure, you wouldn't need to select the type of slab based on where you are placing it. Protastructure will do that automatically. So here is the level of the slab. So the slab thickness is going to be 150 millimeters solid slab we are using in this structure. So we have the concrete cover right here to be 25 millimeters. We'll go by that. So extraction points is going to be beam region. So we have various extraction points here. Okay, it all depends on where you should have that done. So we use beam region right here. So placed by clicking in the provision bounded by the beam to be able to insert reinforced concrete slab just like this. Okay, so the load on it, we have not actually get it done. So navigate to the loading options. So here is the safe weight of it. So the safe weight of slab is being gotten by multiplying the thickness of the slab by the unit weight of by the concrete density, which is 25 or 24.5 thereabout. Okay, so you get this 3.6 kilonewton per square meters right there. So the additional dead load due to the partition and finishings, you will take that to be 2 kilonewton per square meter. So the imposed load, this is for residential structure, so I just use 1.5 right there. After which, click on the update. So this particular slab we have placed, slab X1, will be updated. So with having that update, we start to place the rest of this slab. So we leave this provision open because it's for the staircase. Alright, so in this, we may not necessarily get this beam here. We get that beam up. So let's place a slab here. We'll remove this beam here. So having a double beam here is not cost effective. So click on the close options. Let's remove this beam, and I will run a wall load there. Okay, I will show you how to do that instead of having a beam, because this area is not up to 30%. Alright, so select this slab right there, right click, hit properties, use it here successfully, and then click on the close. In this cantilever slab, I will show you how to apply a cantilever slab right away. So we wouldn't need this beam, just as I've said earlier. Get rid of that based on the architectural plans. So if you get back to the architectural plan right there, you will actually notice that we wouldn't need this beam. So you can see here, this is a suspended slab right here. Okay, cantilever slab, you can see it right there. Alright, so there's no beam connecting to it. Alright, so we proceed. So having placed the reinforced concrete slab successfully for this cantilever slab, because this is the first floor, you can see at height 3 meters. Okay, So we need to place a cantilever slab. You can use this property of this slab, then come over to the provisions and change it to the slab type 12. So after which you can see these cantilever options as pop up in this slab dialog. So come over to this provisions. Okay, so if you check very well in the 3D of the structure, you will notice there are some balustrade works along here. So these things are load. Okay, so we will approximate that load. There's parapet loading. Okay, we approximate it to be 5 kilonewton. Okay, per meter run. Alright, so the length of this cantilever is supposed to be 1,200 millimeters. So we just need to pick the first point, pick the second point, and place it outside here. So you have something of this kind. So here is the cantilever slab being placed and loaded successfully. So you can now see 5 kilonewton load along the edge of the cantilever slab successfully. So after which you just have to close this. Okay, now we want to set stories because we are only having one story. You can navigate to the 3D to see what you've done so far, and then you have this. Okay, you have this. So this is the cantilever slab and the balustrade load along the edge right there. Okay, so let us generate stories. So you click on this stories, right click, come to insert stories. So the next story we should be having is going to be the roof level, because it's only one floor that we're having in this structure. Okay, so you click into right there. Mind you, default stories is 3 meters. So click right there, yes, options to get that up. Alright, so at this first floor we are having a cantilever here. Alright, but that is not an issue. We'll have to proceed, okay, to generate these stories right away. To generate the story now, you will get back to the stories, right click, click on generate stories. So the target stories, source stories is going to be story 1, target stories is going to be story 2. So what do we have at the roof level? We have the slabs. So remove all of that. Okay, click on OK to have that generated. The reinforced concrete columns and as well the beams being generated successfully. So we have this. Alright, so we are now going to work on these reinforced concrete columns. As I said earlier, we wouldn't have beams here. We don't need to have ROC beam, so just delete that. OK, options. And also this column is a slender column, so we will actually get rid of this first floor of that column. So this one now we will make it slender. So to make this column slender, what you have to do, select these 4 ROC columns, right click and select property. In the property dialog, come over to line story where you have 1, click on edit, and then you have 2 right there, click on OK. So this has extender column to the foundations. So you can see we're now having support right there. Okay, so we proceed. We need a beam, so we will use that property to connect this beam onto this column provisions, just like this. Alright, we also need a roof beam right here, just like this. Okay, click on closed. So this is what the whole things are supposed to look like. Okay. Alright, so we make progress. We have to insert the wall loads, but by then let us edit the stories. So if for instance you wouldn't want to maintain 30 meters for the stories height, you can right click and get to the edit stories. So in this edit stories dialog, what you need to do, already we have 3 meters of the stories. So if your first floor, maybe you want it to be 3150, and then this other floor should be 3 meters. Okay, to the roof, you can allow that. Then you come over to the foundations. You want your foundations depth to be 1.2. You can easily change it right here. And then this is stories bottom level, okay, which is the floor of the floor of the building. Okay, so we may leave it at 0. Okay, then you can just assume roof as normal story. Okay, for the sake of loading. So the structural system, you make sure it's ROC, because that is what we are using as the material. Okay, yes, option. So we have all of that updated successfully. At this point, we will proceed to load the structure in terms of the wall loadings. Alright, so we load the structure. For us to load the structure successfully, you just have to navigate to story 1. But before then, you will notice we are having the depth of the roof beam to be 450. So roof beam is not supposed to assume depth of 450. That is pretty much, and then it's going to be a kind of waste of material. So we will select all the roof beam, select this provision, pick the first beam, hold the control key, hold the shift key, and then pick the last beam to get all the roof beams selected. Right click and then click on Edit Properties. So we can change all of the depth of the beams at once. So we'll change this to 350 instead of 450, remove a thickness of 100 from it. Click on OK to have 350, just like this. Okay, so click on Close. So that has been applied successfully to the roof beam. Now for the loading, you have to navigate to the first floor. So double click right there to get to this first floor. Right. So at this first floor, right away, you will need to click on the loading right there. But by then you have to save the structure. Click on Save. So you can actually click on the load editor now, or you can right click. If you select any of the beam, you can be able to right click, and then you see the edit load options in the drop down menu right there. Okay, but by then you have to navigate to the first floor. There are 2 ways to actually apply load to this structure. So the load we are actually applying to these structures are the sample block load. So this load goes directly on the beams. Okay, this load decomposed to the beams, and then from the beam it will decompose to the reinforced concrete slab. Then from the reinforced concrete slab, from the beam is being transferred to the column directly, and not to the reinforced concrete slab. Okay, so it is actually a sample block load. Okay, so the blocks is 9 inches block. Alright, so for 9 inches block we have about a 2.4 something kilonewton. Alright, for a 9 inches block. But once you now add some additional loading for finishing, now have about 3.4 7 kilonewton according to laboratory test. All right, so this load are directly on the beams, okay, from the beams to the columns and to the foundations right there. All right, so you can apply that by being on the first floor, like moving the grid line just where we are now at the first floor and not the roof level, because we wouldn't apply loads to the roof. It will have to, it's going to be minimal, okay, for the roofing structure. So you click on the load editor. So this will take us here. So in these provisions, you can see these loads you see are the reinforced concrete slab load, but you can expand this beam. All right, get this beam expanded, select the first beams, and then you can come all the way down to make sure you select the last beam to get all of that selected. So this one are the self weight, okay, self weight of the beam. So if you select this, you can also select all of the beam, or one of the beams out of all, and if you pick this first one, hold the shift key and pick the last one, you get all of the beams selected. You can as well filter it to have the beams just like this for you to be able to load it accordingly. Okay, that is the first way to do it. So I want to show you the second way you can do this, which is more perfect. All right, so you can now cancel this, select one of these beam, right click, and then click on this edit loads, okay, or you can use these options right there. Okay, so this will take you to these provisions. You can click, hold, and then be able to update this or use this to check the 3D of this beam. So originally you can see the self weight, that is self weight of this beam, and the load from the reinforced concrete slab. Okay, the load from the slab decomposes to the beams, and from the beams to the reinforced concrete columns. So this generates the reactions of 18 kilonewton on this beam. All right. So for you to now add the wall load, what you just have to do is click on this wall load. Yeah. So once you click on the wall load, you can have the details, the load properties. Okay. So in this load properties, you see wall unit weight, which I just explained. Okay. Originally is 2.4. Okay, for a 9 inches blocks. All right, is 2.4 kilonewton per square meters based on the codes. All right, and then the laboratory test. Okay, but when you now have partitions or finishings, okay, which has to do with the screening, the paintings, okay, and other activities on the walls, now increases to 3.7. Okay, 3.47 kilonewton. All right, so having done this, you also consider the height of your structure, which is the height of the structure is 3,150. Okay, so 3,150 we have our beam depth to be 350, so you have to subtract that the beam depth. Okay, so once you get that beam depth subtracted, which is 350, okay, plus 1,150, so you'll be having there about 2,000. So 2,800 about. So let's just use 2,900 right there. 2,900 just like this. Okay. So for the thickness, here is the thickness of the wall. You just have to key in 225 right there. Alright. So to place the wall right now, we just have to select this. Okay. You can see how to just select the beam. So once you select the beams, the wall loads altogether now give us 15.42 kilonewton per cubic meters. That is the volume, right, of this wall. Okay, so this now increase the reactions to 39.1 kilonewton right there. Okay, so should in case there is a window here, window actually reduce the walls load that actually comes onto the beams. So if you click on this edit openings right here, this will enable you to be able to add a windows. So which will have a window at randoms, width 1 meter, height 1 meter, centralized. Okay, So click on the OK options, and then you have to update to be able to see the opening. So click on the update right there to have the opening. So this have reduced the reactions from 39.1 to 37.5. Okay, it has actually reduced the load that is coming on this particular beams. All right, which most of the times are designed for unforeseen circumstances, and so I always don't add window. I already don't reduce the load. Okay, so you can get back right there to the openings, and then you'll be able to delete yes options to get rid of the Windows openings. Click on the OK options and then update right there to have your wall load and be applied successfully, which is 39.1 kilonewtons as reactions at both ends of these beams. Okay, so I believe this is understood. In area where you wouldn't get it right, you can ask questions in the comment sections. Okay, so we click on the OK options right there to have this load being applied just like this on the structure. So you should be able to detect and know the load bearing beams, and then the beams that is not supposed to carry the load. All right, so you check that out in the architectural drawings. So we want to distribute this load along the beams right there. So you get this selected, right click, and then you can easily copy these loads. Okay, use Ctrl C after getting it selected. OK options. So to place it on the load bearing beams, you just have to select all of the beams. You can use this method of selecting the first beam right there, coming all the way down, hold the shift key, select the last one to get all the beams selected. But in this case, if it is not all the beams that is carrying this wall load, so you now have to check very well. This C beam is not actually carrying any wall load. Okay, this C beam is not carrying wall load, so you have to get rid of that, or you can actually place all the wall loads and then manually delete them off. But if you want to get rid of this beam being selected, or the Control key and select the beam. Right, so that is how you get rid of the beams that wouldn't carry a wall load. Okay, so this beam also is not carrying any wall load, it is just supporting this cantilever slab, so you get rid of that beam. Okay, so I'm just doing this to show you how to deselect beams that is not carrying wall load successfully. So we now have to paste. So you right click or you click on paste load in these provisions. You can see options of paste loads right there. Click right there to paste the load successfully, just like this. So if you check very well, you can now see we have loaded all of the reinforced concrete beams with the wall loads successfully, just like this. Okay, so having loaded these beams, okay, there is a load along here because there's a wall running along here, along this Foyer's provisions, this place. Okay, so let's navigate and then be able to apply that wall load right there successfully. Now the wall load goes along the slab. Okay, it goes along the slab because there is no beam to actually carry it. So for that reason, we are going to be considering a line load. All right, so we consider a line load here. Okay, so to do that, what you have to do is to get to the modeling, and then you will found slab. Oh, sorry, you just get to loading right there, and then you will see point, line, and area loads. Click right there. So in these provisions, we are to use these options. Okay, these options of the line load. Okay, so we have the G load magnitude. Okay, we have also the Q load magnitude. So in the provisions of this G load magnitude, which is the dead load, okay, so we are going to key in the wall load, which is supposed to be 3.47. Okay, the 3.47, you have to multiply it by the height. Okay, when you multiply it by the height, you will now get the total load that is running along that length. Okay, so 3.47, the height of this we are considering is 2.9. okay, because we are to convert everything to millimeters. All right, sorry, convert it to meters. All right, so we have 2.9, which is the wall height we are using, because you are having a beam depth of 350. So we get that to multiply by 3.47 equals. So this gives us 10.06. So we can just take this to approximately 11 right there. So you pick this point. This is where the load is supposed to run across. Place it right there. So you can now see we applied a load of 11 kilonewton per meter along that particular provisions. So click on closed. Then you can navigate to the 3D. Alright, so you cannot have a load right there. Okay, so that load will take care of the wall that is going to pass along that line. Okay, so we are done with this. Okay, and so should the case you want to manually apply a parapet along this roofing, because the structure actually has a parapet right here. You can see parapets all around the structure, so you can also apply this as well using a Protastructure. So how do you do that? You will have to navigate to the roof level by clicking on the story tool right there. On this roof level, what you need to do, you get to the plan view, or you can as well do this. You can as well do this and at the 3D. Okay, you can do this on the 3D. So how do you get this done? To apply that on this roof beam, to design the roof beam, so you can be able to withstand the parapet successfully. You just have to get back to the modeling right there. Before then, save this project. Then click on the reinforced concrete slab. So we have some settings here. So we are considering partition finishing for this case to be 1. Okay, and then we wouldn't have any imposed load, because people don't normally walk around there. Okay, we don't normally walk around there. So what you just have to do, get to these provisions and then get this slab type 12 right there, after which you can get to the cantilever and then be able to give a distance. It is basically 600, sometimes 450, so it all depends, but we use 600 for the sake of this design. Okay, so for the parapet loading, we can take that by assumptions that we have it to be 5 kilonewton per meter run. Okay, so we have to run it along this structure. Okay, so you can just start to place it. So you pick 2 points, the first point, pick the second point, move your hand, but to have that. Okay, do this just like this. Make sure it is not inward, take it outward. Take it outward. So sometimes you find it somehow stressful to place it at 3D. So if you find it stressful to place it at 3D, you can navigate to the 2D successfully. Okay, you can navigate to the 2D, but you can see I am doing it at 3D successfully. Okay, so you just have to continue to place this. Alright, so let's place this one, then close this. Let's navigate to the 2D, like the plan view. Okay, so we can actually do it. You can see it all around. So here are the parapets. So we use this property as well. Right click. So the thickness we're having here is just 120, okay, which we may edit this. This is not used to be as thick as this, so we can just go by let's get all of that selected, or the control key. So we change the thickness of the parapet to 100. So click on its property, sorry, I have to cancel that. Right click and then property. So for where we have edge thickness, you get that changed to 100 millimeters. Click on closed. So we select the first one, right click, and then its property. We continue to place this right there. So we are supposed to take this all the way down right here. Okay. Alright, so we are done with it. Then navigate to 3D and then be able to confirm that you have a parapet loading successfully. Okay, just like this. Okay. So with this, we have actually loaded the whole structure. Alright. At this point, we can now save the project, and then we get into the material settings. Okay. But before we get to this stage, we are supposed to set the project preferences. But you can do that just even after we have done with this modeling and loading. Okay. Project preferences, which has to take you to the settings right here. Okay. Setting center. So in the setting center dialog, you will have to carry out the project preference settings, which have to do with the here we have, you see the name of the consultancy. You can also the name of the person that drawn, design, the client names. So you can always fill this up before you carry out your analysis. Okay, but we will not do that here. Right, so if you want to look at the codes, these are the codes that we are considering in this design successfully. So after which we will still come back here to carry out some settings. Alright, but before then, let's get back to set the materials. So click on the OK options. So for the material settings, we will have to navigate to the modeling tab, building setup tab, and then this material, click right there. So here we go, we have our materials right there. So we have our concrete grade right here. So for the concrete grade, select on the concrete grade, and then you can choose among all of these concrete grades here the ones that will be favorable depending on the strength that you actually wanted. So get that selected. You have to apply this to all of the concrete. So click on the OK options to have that applied. The same thing applicable to the steel grade. So it all depends on what you want. Applied it, and then by then you can set the reverse diameters in these provisions. Okay, so if you click on this edit right here, you can now see a table that shows all the structural members and then the diameter of the rebars as well as their areas and the labeled successfully. So in this structure, you will need to actually select the rebars you actually intended. Okay, for instance, the first column right there, we have the reinforced concrete column, and then you see rebar selected is 10. Okay, 10 millimeter diameter. So we wouldn't want to use this rebar diameter in this structure 13. We wouldn't want. Okay, we need 16 as our minimum rebar diameters. Okay, 20, 25. Okay, we wouldn't need 32. So the program will have to carry out the analysis of the structure. During design, the program will select between these three rebars and use it in the design of that structure. Okay, we can choose diameter 12, but based on experience, I don't normally use diameter 12 for reinforced concrete beam design. So here we have wall. We didn't have wall. We don't have wall in this structure. So here is beam. So the same thing applicable to beam. We need 16 minimum and maximum is 25. Alright. The next thing, reinforced concrete slab. So we can use 10. We need 10 right there. So I have 10 checked. So we don't need 13. So we need 12. 10, 12, and 16. Okay. So for the foundations, here, this one, we need 12. Alright, and then we need 16. These two will be suitable. Then for the links, which is the steel up, we need 8, and then 8 and 10, then add 12 and take the rest. Okay, so we have this. So for the generic, you must not leave this generic unchecked. So you must check 1 or 2 reinforced bar for the generic right there. Okay, so after having that selected successfully, what you just need to do is to click on the OK options and then click on the OK again to complete the material settings. So we have set materials. Click on the save option. So the next important settings we need is the soil bearing capacity. So for this structure, because this is a REIT project, the soil bearing capacity is 140 kilonewton per square meters. Okay, that is the soil bearing capacity on this construction site. So I will be showing us as well where you input that right away. You have to navigate to the analysis tab, click on the building analysis. So in the building analysis dialog, you will have these provisions of loading combinations, material, and the rest of that. Okay. So in the pre-analysis tab right there, you have the project parameters and loadings. Okay. So you can as well get back to your loading combinations here, as well as wind and story loads successfully. And then you can also edit the material through these provisions as well. But we have edited material, just as I've said earlier, the unit weight of concrete we used is 24 kilonewton per cubic meters. Right here you can see. Okay, so for the soil bearing capacity, we need to set that first before we move into the analysis provisions. So to set that, click on the setting center. So in the setting center, navigate to the foundations. So over here, you do some settings on the foundations parameters, which is the allowable stress of the soil. According to the soil report, we have it to be 150 units per square meters. and then for the footings, default part footings, you see it's rectangle, change it to square. Alright, so the program is going to design it as a square footings. Alright, but if you want it to maintain rectangle, you can as well choose that successfully. So what you also consider here, the length concrete thickness. Okay, you can leave it at 100. So this length concrete simply means blending, and it used to be 50, so you can change that successfully. The street footings cantilever length is this. Okay, wouldn't want to change that. Alright, then we have to now check the minimum footings width. Okay, so you can actually adjust your minimum footing width right here. So let's just leave it at 1 meter, the minimum footing width. Okay, so another thing you look at the steel bar selections. Okay, now this program was designed at default top and bottom footings. Alright, but if you wouldn't want it to be designed top and bottom footings, what you need to do is to uncheck this show planned bars as top view. Okay, check these two provisions and then remove this use to top. Okay, options. So if you are uncheck these three options, it's going to design as a single reinforced footings. Okay, but as well during the editing of your foundations, you can't make that change successfully without changing it from the provisions. Okay, so this is the necessary changes you need to make to the foundations successfully, after which we will also have to select the soil vertical subgrade coefficient. Okay, this is 50,000 kilonewton per kilometers. So if you have it on the soil, you can equally select this select options and be able to choose the subgrade coefficient that you have on your soil report successfully. So if it is not seen in these provisions, I think you can key it in here manually based on what you have on your soil coefficient. So having done with this, you just have to click on the OK options and then close this first. The reason is because we need to save this project. So click on save to save this project. So I'm taking you through the right way to carry out a structural modeling, loading, analysis, so that's design. Okay, so don't forget to like and subscribe to this channel. Okay, if you have any questions, you can reach across to me through the comment sections or through WhatsApps, to my WhatsApp handle, or you can also drop your questions at my Telegram handle as well. Okay, so we make progress. We want to go into the analysis of the structure. So click on the build analysis. So again, you come to the analysis right there. So at first you need to check the structure to be sure that you don't really have any unnecessary warning or error. So click on the check right there and start. So this is going to check the structure for errors. So we have only one error in the structure, and what is it? So you have to scroll up to check. So you see over here, story 2 slab XDs has a very small area. Okay, check the slab geometry. So at story 2, which is the roof, okay, they're telling us we have a slab that have a very small area. Sometimes if your first concrete slab area is very small, the Protastructure will detect it as being very minimal. Okay, meaning you can take care of that during editing. So you wouldn't want to add that up right there. So if you check very well, see 2x5. So let's check that up. Close this, right? And then I think the slab should be a sphere somewhere here. So 2x5, okay, 2x5. You can find it here. This one. So get it selected. See this one is the slab 2x5. Okay. So that is not an issue. Okay. We can proceed into the analysis. So click on the building analysis again. Go to analysis tab. So now just click on building analysis to carry out the analysis of the structure successfully. So you have this batch design option. So If you want the program to actually analyze and design the members, you have to get all of this selected. Okay, but you can first check your structure after analysis before you now start designing. Okay, but let's just check these two provisions, meaning we are telling the program to analyze and as well design the reinforced concrete members, the beams, the columns, right there successfully. So click on the building analysis. So at this stage, analysis is actually done. So it is now designing the column reinforcement. So now column reinforcement design is done. Is this designing the beam reinforcement, and then the reinforcement selections options is check steel, don't select steel when previous bars are insufficient. So this is the option it is using for the design. Okay, which I will show us these options subsequently as we make progress in this course successfully. So over here, building analysis completed successfully, and then another check that is important is relative story draft satisfies the limit. This check is very, very important, and then you consider this most important, and you don't play with it when it comes to an IRS structure. Okay, let's click on the OK options. Okay, so analysis is done. If you check over here, you can see we have a green check right there. We're done with analysis. You can proceed to the post analysis, and then you can check the behavior of the structures using the display analytical model. So clicking these options to have the analytical model display successfully. If you come down, you can see structural model export options. So you can move this structure to heat type and SAP 2000 so as to be able to check also and to confirm that everything done here is right in order. Okay, so here we go. We have the structural model right here. Okay, so you can check the reflections, the animation behavior of that structure right there. So it's a first floor, and then you can see the parapet loadings right there. Alright, just like this. Okay, so you can take the behavior of the structure in respect to the loadings. Okay, you have the dead load, that is respect to dead load. Also check the behavior of the structure in respect to the live load. Okay, and check that, and then to be able to view the deflections, the moments by activating the diagrams. Okay, and then M3 is for the bending moment diagram. So M2, V2 is for shear force. So you can check all of that successfully. Okay, and then be able to navigate through the load cases and as well as the combinations to see the behavior of it on the structure successfully. So after which, get back to the physical model. So here we go. We now start to check the members. Okay, the one that has passed and the one that fails, in order for us to correct it successfully. So we can double click on story one right there. At first, check the column. You notice the column has not been designed. Okay, so what we can do that using bash mode, because it's having a crossed, red crossed sign, meaning it is not being designed. Alright, so then click on this and then come over to, you can design all of this reinforced concrete column if you choose the first options, these options right here, ROC columns / wall design. Okay, and then ROC column / wall design active story. Okay, but this is just a story building, so let's do all of the reinforced concrete column design successfully. I have to get this expanded, and then you have all of this just like this. Come over to the column design, batch mode. Select that options. So this is the options that the default design was used. So select these other options, reselect all bars and click on calculate. So click on close. You can now see all of these bars, AFS concrete column has been designed successfully. And then you see the U ratio is very encouraging. Very encouraging U ratio that we're having. So all through is 4x16 diameter reinforcement, and then we have the links expressed as 2 to 5. So we have this column failing. Let's check what makes it to fail. So we have these columns, bidding analysis combination results not found on that columns. Okay, so this is column C1. So you need to check the column C1 to know if it is off the grid line. So basically what causes this is when a column is not actually connected to a grid lines, right? It causes this. So we have 1C1. Okay, so 2C1 have been designed, 1C1 has not been designed. Okay, so click on the close options. So see the column right here, this one. 1C1 has not been designed. Okay, that is not an issue. We'll look at that later. Okay, so having done with that analysis, we navigate to the let's check the beams design as well. Right click, and then we look at all of the beam design. So we have this, use beam batch mode, select all bars, calculate. Okay, click on the close option. So check the beams. All the beams has been designed successfully. So this one has failed, this beam. So let's check that, what happens. Okay, the formations limit exceeded. All right, so this is based on the deflections. So let's check what happens. Yes, options. Alright, so how this reinforcement be selected. Let's just expand this. So we are having the deflection check failed right here. Deflection check is failing right here. Okay, you should know this beam. So this is the concealed beam. It's because of the 150 thickness that we assigned to this particular beam. So there's a deflections right there on the beam. So what happens is to correct this, you have to increase the depth of the beam. So to do that, you will just have to take note of this beam. So this is beam B9. Okay, get back to this beam options right there. So here is the beam. So B9 is the last one. So the thickness 150. Let's use 200 right there. Okay, so after which beam design parameters, just click on that. So in these provisions, click on the OK options and get back to the area to check if that has passed. See, it's been corrected now. So everything has passed and it's fine now. Click on the OK options. I believe the beam has passed now. Okay, so everything has passed design in terms of the beams. Okay, but one more thing you need to do before you produce your drawings. These beams, you have to make sure you interact these beams. Okay, interact it in the sense that I want to show you, not for this is simply supported. Okay, so you can also as well change this to 3 Y20s, and then here this is 4.2 meters, change here to 2 Y20s, and then this is having a support weight bars. Okay, 1 Y16s right there. So it's not bad. The settings is good. Click on the OK options, come to this, and then click on the interactive design right there. So this is a continuous beam. So when you see have a continuous beam like this, you have to interact it. This top bar, so you have to change it to left, and then this other way, you see short, extend left and right, make sure it laps, okay? And then after which, get rid of this, and then select this, make sure this laps, okay? Get rid of this as well. If you want to have a wet bar, so we can continue to place one wet bars along the side of the reinforcement, okay? So with this, check, we have to also check the span of the beam. Can increase this to 3, although 2 has passed, but just increase this to 3. Reinforcement bottom, because this is 4.7 meters. Can also have 3 top and bottom right here. Okay, so this is interactive design I'm doing. So this is what you are supposed to do to all of the beams, okay, before you produce your drawing successfully. Click on the OK option. The same thing apply to all of that, just as I've said earlier. And also, you can come to grouping and be able to do these beams. It all depends, but we wouldn't have much similar beams here to group. If not, you come to automatic grouping, and then you can group beams as the within floors, okay? So if you click in that options, click on apply. So this is going to group beams within floors. So most of our beams here are not similar, so we wouldn't have it much grouped, okay? After which you close this. At this point, we want to design the foundations, okay? So to design the foundations, also you can confirm that everything is fine. It's no longer red crossed in the structural panels right here. We see green check right there, meaning everything is good with the structure. So we have to now navigate to the floor plans right there. So this is the normal floor level of the structure where the green line is, okay? From the green line downward is the soil. It's beneath the soil, which is the foundation level, okay? So we'll take time to design the foundation successfully. So stay connected and then stay attentive. We proceed. Navigate to the plan view of that foundations level. At this plan view right here. So you just have to select any of these foundations. Sorry, any of these columns. Okay, and then to be able to insert your foundations successfully. But before then, you can actually enable the axial load that is actually coming to the foundation from each of these reinforced concrete columns successfully. So I'll be able to enable that. Proceed, you have to save this project first, and then for the axial load you have to get to display options. In this display, you come to this visual interrogations. So in the visual interrogations, you navigate to the columns display, and then check axial load. Come to the loading provisions. So you can check axial load based on dead load, axial load based on live load, then axial load based on unfactored dead and live load, which is this one. Click on the OK options. So click on OK, and then you come over. You can now see the axial load that is on these columns. Okay, so the footing size is being designed based on this axial loads that come on each of these columns. That is why there is no way you do your design and then you have all of the columns you have all of the footing sections to be the same. It must not be the same. Okay, it must not be the same, because the columns, okay, is not carrying the same axial load. Okay, so since we are dealing with the square columns, you can actually click on this, right click, and then over here you have insert part footings. So in the part footing dialog, you will actually have to check if actually the sections you selected is enough to withstand the axial load successfully. Alright, so design has been done successfully. What do we have here? The sections selected for the footings is 1.2 by 3 right there. So we want to make it square, so we have to increase this to 1.3 by 1.3 successfully. Okay, so for the depth, like the footing thickness, we'll change it to 350 right there and check if it will pass. Click on design right there. Okay, this has changed to 400. The reason why it is not responding to responding to 350 is because the 450 depth is the minimum depth that we have set. Okay, but we can go and adjust this to 350 as the minimum. That is when it can be reduced successfully. So take this to 1.3. okay, after which we'll check and make sure that all of the shear check has passed design successfully. Now come to the 3D provisions, and then you have the 3D bars reinforcement generated. As I said earlier, it is going to be top and bottom, as you can see right here. But if for instance you wouldn't want it to be designed top and bottom, you can come over to where you have rebars right there and then uncheck these two provisions. Okay, once you get that unchecked, you can now see that you can as well get rid of get rid of these top bars. So if you get rid of the top bars, you can now see get rid of this as well. So here we go. You see it is now only bottom reinforcement. There is no top any longer, and then you see the design is still passed, meaning all of the top reinforcement is just a waste of bars and resources. Okay, so these are the things you consider when you are carrying out your design, so as to have an economical and good design successfully. After which you click on the OK options to insert the reinforced concrete columns successfully. So the footing size right there is 1.3 by 1.3. Okay, so if you want to check this manually, you can actually check this by using the soil bearing capacity. Okay, the soil bearing capacity, or you can see it here. We change it over there in the settings, so let's go and confirm that right away. Okay, so you can come to the setting center right there and then come to these provisions foundations. The soil bearing capacity is 150 right there. Okay, so this is the minimum part base. Okay, so if you change this minimum part base here to 350, what I explained earlier, you can be able to actually get it adjusted over there. And then the allowable stress of soil is 150 kilonewton per square meter. Click on the OK options. So if we edit this again, click on this property. Now we come over here, you can now be able to change this footings thickness to 150 right there. See, it works now because it's been adjusted over there. Okay, so after which click on the OK options right there to have the footings depth, which is D, being changed successfully. So you can also check this, just as I said earlier, whether it is divided by the soil bearing capacity to get this footing size. So let's check how effective this program is in terms of footing sizes. Okay, so if you have 1846, alright, sorry, 184.6 right there. So you divide this. Okay, you have to divide this by 150, which is the soil bearing capacity, and equals, you will have 1.23. So originally it was 1.2 by 1.3. Okay, so some other factors will be applied to it. Okay, factors of safety to make it that 1.3 right there. So this program is effective, right, in terms of foundation design. So in this case, this column seems to be closed somehow, so you can make them a combined footing by selecting all of the two columns and then insert combined part footings right there. Alright, so you have combined footing 1.5 or 1.1 right there. Okay, so if you also navigate to 3D, you notice this double reinforce. Okay, so you always come back to the rebars to make sure you uncheck these two provisions to have it a single reinforce footings successfully. Okay, but if you change it at the settings, you wouldn't have time for all of these other settings of removing the top bars. Okay, click on the OK options to have the combined footing placed successfully. So this should be a single footings. Okay, so we can also design all of this together as at a go. So click on the insert part footings. So this is going to create a dialog just like this, and then in this the way just have to redesign all. Click on design all. So give it some time. So design is done. So we can see we having this to be almost squared footings. So we can correct this to be, if you change it to 1.3 to my file, you can see, so make it 1.3 by 1.3. Same thing here. Here is 1 meter, 1 meter. This is 1.1, 1.1. Okay, so the depth you have here is we have a depth of 350 right here. Okay, so after we click on OK option to insert the footings, just like this. Likewise, we can design all of this at once. Get all of that selected, right click, and then insert part footings. So you can just click on the design all. You can also design selected. Okay, so the options of design selected. So you can as well group this. Okay, but let us design them individually. All right, so click on to design all. Alright, so all of the structural footings has been designed successfully. So you can now have to interact. If you want it to be squared, so this one is 1.1. This is supposed to be 1.3 by 1.3. This is also supposed to be 1.3 by 1.3. Okay, so you can see 1.3 by 1.3 being repeated. So for it to be repeated just like this, you can now consider grouping. Okay, so you can group select it. Okay, so you have to check all of the 1.3 by 1.3. Okay, and then all of the 1.4 by 1.4. Okay, so this was 1.5, 1.3, 1.2 by 1.3. This 1.3 by 1.3. Okay, so you just have to take a few time to make sure you actually interact and get the column footing squared, just as I'm doing, just like this. Okay, so you can select this one, like this one. You can hold this control key, so to have multiple selections, okay, of your choice. So these are the 1.3 by 1.3 footings. I'm selecting these ones, okay, these ones, and the last one. So you can group selected to be one footing. So click on group. So this has been grouped successfully. Alright, it has been grouped successfully. So you can also proceed to group 1.4. Okay, just like this. It's a 1.4, have 3 of 1.4. Click on grouped right there to group selected as well. So this has actually shown you how to group. Okay, so we get all of that grouped successfully. So in each of these group, like the 1.3 group, you can now select it, and then you'll be able to select the property to get it edit. As in, you can now edit the, here is to edit the parameters. Okay, I mean to make sure you edit the footings, rebars detail, as in you can decide whether you want to have a double reinforced part footings or a single reinforced part footings. Okay, by double clicking on this. Okay, so once double click on that, you see this footings as felt. Okay, you can as well increase this to 1.1 to make it pass design successfully. Okay, if you check here, you notice it is a double reinforced. Okay, so you can come over to the rebars and then uncheck the top rebars right there. Check HT pass design, click on OK options. Alright, so this has been successfully edited. Okay, for the 3.3 by 3.3, just double click right here. So once you double click right there, it is going to enable the dialog where you can carry out your editing successfully. Okay, but for the group footings, it may not necessarily enable the dialog. Okay, so everything has been designed successfully. Click on the OK options to insert your footings, a part footing, just like this. So the same thing applicable to this other one. You can as well insert it successfully by clicking on the insert part footings. So in these provisions, what you just have to do, select design all and design all. So at every of your work, you make sure you carry out saving. Okay, so you save your work successfully. So this one is going to be combined. Select the two first click columns and then use the insert combine part footings options right there, and then you have this. Okay, we check this, you can see. Alright, this has been designed successfully. Click on the OK option to insert that. So these other two columns, we are going to also design it as a combined footing. So you use the insert combined part footing option. Alright, so I have this one by one, click on the OK option. Okay, so we are done with this. You can select this, right click and then click on the 3D. So you have your model just like this. Okay. Alright, so having done with your design, now we want to produce the drawings of this design successfully. Just as I've said earlier, before you produce the drawings of the design, you will have to carry out the interactive design of the beams, just as I've done. Okay, so now for the design, okay, for the drawings, you will need to do some certain settings right there. Okay, before you carry out your drawings. Okay, so we click on save first to save this project, and then go to setting center right there. In the setting center, so you navigate to the beams. So in these beams, come to this containment or to this detailed drawings general right there. Check the beams right there. So also check the sections. This has got about 3 sections, so we wouldn't want it to cut 3 sections. We need only 1 sections. Okay, so we restart this as well. Come to the steel bars, these options, and then we have this in place like this. This is good enough. Okay, also you can come to the labeling, label, and bring this out. Okay, having known that the column sections is 2 to 5 and 2 to 5, you can also hide the columns tag. Okay, just like this. This setting is fine. Click on OK options and then save this project. Before you produce the drawings, you have to detail your reinforced concrete slab. Okay, for you to do that detail, you need to navigate to the story 1, which is the first floor, and navigate to the plan view of that. So here we go. The slab, we'll have to detail it. So you need to navigate to the modeling tab. You see slab strips. Click right there. So this will bring up a slab strip dialog just like this. So we are dealing with analytical strips and not FC strips. Okay, so you see boundary conditions right there. So out to out is the center, which is bulb to bulb. So if you are slab to slab, we'll use the center. And then at first, directions you're going is X direction first, which is the horizontal direction. So pick this first point. Or use this control key to have a straight line. Click to insert the okay, so here is the strips. So you can now see we've drawn a strips. This is white and selected, spacing to 50 right there. Okay, and then in the horizontal directions. So we still continue to place the horizontal rebars successfully of the reinforced concrete slab, just like this. We'll have that. So we'll also have this. Okay, white item is selected successfully. Okay, so we get this across here and placed it right there. As well as get this across here, place this. Okay. Alright, to use for this one, we have here to be slabs, okay, and we have to be bob. So we use start at slab and end outside of the slab. So slab start inside the slab, just like this. Okay, so you can see here it's a kind of continuation. There is no return as we have returns here at the top bar. So that is the difference. Okay. Now, in these provisions, we have cantilever. So what you have to select is cantilever. You have to start inside slab and end cantilever. Okay, so this is have to move vertical. Okay, so we have okay, we can start inside bob, which we have other slab here. Okay, so here is checkers provisions. Okay, just select here all the way and outside of the cantilever and click. So this is going to design the cantilever. You can see cantilever has been designed as top and bottom. Okay, right there. So we decide it as applicable to this. In these provisions, it's not the cantilever, so just choose bob. Okay, then you can pick from this outside. So sorry, we're supposed to change the direction, so change here to Y. Okay, so we are moving in the vertical directions. Pick that. So this is entering this panel. For that reason, escape it and then pick these provisions. Hold the control key and use your hand to get that design successfully. So this is applicable in this provision to get all of that slab design. Okay, so with this we have designed all of the reinforced concrete slabs successfully, and then the details, as you can see. Okay, so the next thing we are going to be designing now is the parapet. So now we get to the parapet right there. Okay, so we get back to the slab strips. Okay, analytical strips. So now we are going to start inside bob and end outside of the cantilever. Okay, so where we now need to click here. So what is the direction? This is X, change it to X right there. So, and you can change this to 1, the number to be 1. Okay, hold this and then hold the control key to have a straight line. Place your hand, have that. So that has now generated reinforcement. So once you click on the update, see it's being corrected. So this is the rebars for the parapet, alright, in the X directions. So we still need a rebars here. So just select the first point, or the control key to have a straight line. Then you have your rebars for the parapet. So this is supposed to be the Y, like the vertical. So you select Y and click on the update right there. So this has changed to the Y. Okay, so the next one is supposed to be X. So you have to have that. Select X, update. Okay, so this is basically for your parapet. Alright, so you can continue to play this all around, or you can use these rebar selections for all of the parapet design successfully. Okay, so let's add one here in the Y direction. So this is not, you have to undo this. Okay, that is not giving us what we intended. Okay, place it again. Then you have this. Okay, direction is vertical, so you can always change it from here. Update. Okay, so here now it's going to be horizontal. So you have it right there. So select X, click on the update. So always follow this procedure I'm using to place this, so that it will work fine for you. Just like this. This is X, which is correct. Okay. Also have this as X. Okay. This is Y. Place it as X, and then can change it, update. Then continue to play this successfully. Right, so we have almost all of the parapets being designed successfully. This is not producing, so undo that, get back to it. So we'll have this, place it again, and then click on update right there. It's not responding, undo that again. So use X for Y, and you have that generated. Now change it to Y and update. Okay, same thing here. Alright, so this is X, change it, update right there. Okay, so this is how you design the parapet successfully. So having done with this, close this dialog. We are good to go now. Save this project. So the next thing we will do at this stage, we will now produce the drawings of our designs. Okay, now we go to the 3D. So you have this. Okay, so for you to produce the drawings of the design right away, what you have to do is you have to navigate to the drawings and report tab right here. Okay, so you will be using Prota details to generate the old drawings of the structure. So click on it right there. So clicking on this is going to load the Prota details successfully. Okay, so here is Prota detail. So in this, you can produce all of the drawings at once, or you can start by creating new drawings. Okay, so click on auto generate details. Once you click on that, draw detail dialog, click on draw right here, and then click in these provisions. So this is going to generate detailed drawings of all the structural elements, foundations, GA, the beam arrangement, and as well it is going to generate the columns details successfully. So it is done. Over here you check, you can see your beam details. Okay. Having seen your beam details, so this is the concealed beam we designed. You can see the sections, the way it looks, 4x16s right there. Okay, so if you also check here, you see all of the details is being generated successfully. Alright, okay, so what you will now have to do is you will have to also scroll down. You see your foundations. Okay, some of these foundations have been designed as top and bottom, so you can now see the real bar details of it, the way it's been labeled successfully, and all of the details right there. Okay, so we are now set to move this to AutoCAD. All right. So you click on this export DWG file, right click and click on export right there. So this drawing is named as drawing 1. Click on export. And this is going to load AutoCAD to move these drawings straight away to AutoCAD successfully. So here is this drawings being opened. So you double click right here to open it in AutoCAD. Continue opening to have this. Okay, so now you have these drawings now in AutoCAD. If you check very well, notice the drawings are not well, edited. They are not well presentable. Okay, so to make this drawings presentable, you will now have to use a Protect company detailing template to detail these drawings, so it looks very nice and okay. So for you to use Protect company template, you will have to navigate to launch the software. So here is the Protect company detailing software. So on this software, the link to get this software is in the description of this video. So since we are building on part foundation, so you use these options. Okay, part footings, just click on it once. So this is going to open to us a part footings drawings in AutoCAD well customized. Okay, so you open this, so you have this part footing drawings well customized and arranged. Okay, just like this. Okay, so what you just have to do now is you navigate to the drawings, drawing 1, which is the one you actually brought from Protastructure. So having a look at it, you can see the way the drawings are. And at first I want to copy this beam back to the template, and then you see the changes that we made to this beam successfully. So let's copy this beam and the sections just like this. Right click and then click to copy it, clipboard. Get back to this template, Protect complete template part footings. So let's paste this beam here. So we compare what the template will do to this particular beam. So you can now see how this beam now look. So you can see the difference between this beam and this one. Okay, see how this one looks. Now the one you pasting the template, you can see how it now looks. Okay, so all the text or the rebars has been edited successfully. So having gotten that, what you just have to do is to copy all of these drawings right away. You copy all of these drawings, so click on copy right there. Okay, and then open the Protect template. So right click and paste it all right here. So you just have to pick your instructions point to place these drawings successfully. You can now see how the drawings now look. Okay, you can see it right there. Now get back to the drawing 1 and see how this ones looks. See how this one looks. Onto the template, you can see the difference. So automatically this template has edited these drawings to ease your editing experience. So you just have a little work to do on these drawings in order for you to be able to get the drawing set for printing successfully. Okay, so you can get the template, the link for you to get this template software is in the description of this video. Okay, so if you build on part footings, you will use this one. If you are designing steel structure in Protastructure, you will use this one. If you are designing steel structure in Tekla structure, you will use this one. Okay, if you are designing concrete building pile on AutoCAD in Prota, you use building on pile foundations, raft on beam, building of white strips, and as well as floating raft right there. So once you click on any of these tabs, this is going to launch. Or for instance, building on floating Flat Slab Raft. If you click on it, it's going to launch a template. Okay, the software is going to launch a template that has to do with building. That has to do with building on the floating raft. So this is how floating raft is being, detailed at the foundation successfully. Alright, and then you can now see the detail well arranged. Okay, so the same thing applicable to if you want to, if you just done your design in Protastructure, you can click on this particular template. So you can actually see the differences between Protastructure drawings. You can see Protastructure drawings. Okay, the way it looks. Let me maximize this. Okay, so this template, you can see it's very, very effective. This is Protastructure drawing, the way it's being presented. Okay, and then the other drawings, which is the Protastructure drawings, you can also see how it's being presented. Okay, so if I activate this now, so this is for Protastructure drawings. You see how it's being presented. You can see the foundations. Okay, that's the difference between drawings on the Protastructure and then drawings on the on Prota. So this is Prota drawings presentations, and then this other template is for Protastructure drawings presentation successfully. You can see it right there. Okay, the same thing applicable to Start Pro. Right, if you do a design in Start Pro, you can use this Start Pro template. And also another benefit is a free course. It's a free course. So this free course is being updated. So if you get this template, you have access to this free course. Okay, before you click on this, you see online. So you must be online to use this 4 tabs as well as this one and this. Okay, but all of this you must be offline to use it. Okay, so the link to get the template is in the description of this video. By the time you click on the link, you'll be able to get this template and use it successfully to edit your drawings, okay, for pipe, footings, and the rest of the foundation successfully. Alright, so if you have any questions, you can always ask, okay, through the comment sections right there, or you can, chat us up. Okay, the link for our WhatsApp is in the descriptions of this video. Okay, also the link for our Telegram group is also there. You can reach us for any questions or concern or business. Okay, we are very available to attend to you, right, at all time. So also the link to get these architectural drawings is in the description of this video. If you also need all the structural drawing, okay, detailed drawings of this structure, you can inbox me. Okay, I will send it across to you, structural drawing and architectural drawing, the mechanical drawing as well as the electrical drawing of this, because this is a project. Okay, so we want to bring the course to a stop here. Okay, don't forget to like and subscribe to this channel. So freezing, stay tuned for more advanced presentations of this kind. Also stay safe. See you in the next presentations. Bye for